Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, everyone. Welcome back to another exciting edition of IT Pro TV. I'm your host, Vaughn Smith, and this is our Cisco Cloud Fundamentals series. And we are coming back with a part 2 in our Cisco Unified Fabric topic within the cloud networking big topic. So here is Mr. Ronnie Wong to help us again. How are you?
I am doing well, Vaughn. Thank you again for joining me as we head into our part 2 here on the Cisco Unified Fabric. We've talked about so many different things here, and it, of course, required a part 2 because there's still some more details we need to get into. But before we get started, Vaughn, let's go ahead and at least do a mini review of what we talked about in part 1, because I don't know how long it's been since you actually went from part 1 to part 2. Sometimes you may have actually gone, oh, yeah, let me go ahead and head into part 2. Sometimes you might have actually turned it off, and then a few days later, a few weeks later before you came back, so I want to do a little bit of a review.
Yeah, and you can see that we're wearing different outfits. So that means it's a different day for us. So
What? Oh, yeah, that's true. I'm joking. All right, yes, that's.
I'm like, wait,
there is
this
no
is
doubt.
like the first episode we were filming today, right?
Yeah, you never know. So yes, that's what we're going to do. We're going to pick up on that, and that way you get the kind of flow getting back into this. So I try not to do too many part 2s, but every once in a while I tend to talk a lot, and that's what happened here. Okay. So with the idea of the Cisco Unified Fabric, remember that what we started off with and we talked about as we go to my screen here, okay, is that the traditional way that we've done networking, okay? So here's the idea of the traditional campus network over on the left-hand side, and where we divide it up into the core, distribution, and access layers. And the whole goal behind this type of access is really what we focused in on as what we call north-south traffic, okay? And this, of course, is for us, or, is that when we try anything, right, it's about making the end users experience the best that they can. They can get access to the data relatively quickly. It is the whole focus, of course, is on that ability to get access to the resource, and that resource gets delivered back to the user, okay? So that tends to work until we start talking now about the idea of a data center, okay? A data center's focus is not on north-south traffic. Don't get me wrong. It's important that we can get, of course, our end users getting access to data. But the idea and the focus is different in this way, okay? So when we talked about this idea that the idea of the data center, now if I kind of refocus in, okay, and we'll kind of go over here so that we can take a look. We focus in on this, and what we talked about here is that the attributes of a data center now come into play, where what we want to do is ensure that our data itself, that there is great availability, which means the ability to recover when there's a failure, the reliability of getting access to our data. So all that's actually about availability. The scalability, the ability to add in more as we need to, as our data continues to grow and change. We might need to add in some additional servers. We might need to add in some additional network infrastructure. We might need to be able to do that, that we can expand it easily as needed, as we want. Flexibility, sometimes we might find out that we don't get to keep all the structures the same, and the different types of data that we tend to run, we don't want to have to reconfigure our entire data center just to make it work as well. So we want flexibility to be involved in this, as well as manageability and, of course, virtualization, which we described at the most fundamental kind of conceptual layer, the idea of pooling, the idea of partitioning, and, of course, the idea here of segmenting or abstraction. I said segmenting, but I mean abstraction, right? So those were the fundamental things that we talked about here, and that the whole goal behind this is, of course, to ensure that we eliminate some of the problems that we normally had. So we already talked about the idea of the traffic direction as that we're changing from north to south to east-west data, which means it's more important that we keep the connections between all the devices within our data center up here on the upper right-hand corner of the screen than it is about us trying to deliver the data to all the end users. The access layer connections, normally in a regular traditional campus network, end users tend to have a single connection into the access layer, whereas in the data center, we tend to have multiple connections, reducing the ability of failure domains and also adding in more access layer connections so that we end up ensuring that we don't end up losing the connection as well. So all that's pretty much where we got to what we were describing at the very end. And then we talked about one other concept as we continue to move through here, okay, as well, which is the idea of virtualization, or what we call VDCs, right? The idea of the virtual device context. And this is where we were able to essentially say that if you took something like the Cisco 7000 or 9000 or whatever, which one that we want, I just said Cisco 9000, okay? So we can actually create virtual device contexts. And that means that each one of these is actually a virtualized copy. I think right before the show we mentioned the idea of a replica, okay, that we can actually mimic to be able to do this. And what does that allow me to do? Okay, if what we have is not 4 or 5 physical switches now, I have one physical switch that then within it, I can actually sub out and treat as if there's actually 4 individual switches. It allows for tenants to be able to manage their own switch. It allows for them to treat it and do what actually they want to with it as well. So that was the whole goal behind this. So this idea of the virtual device context, it really does provide a lot of the different redundancy that we need, or eliminate a lot of the redundancy and the management things that we have to worry about, because if not, we'd have to buy multiple physical switches for each particular client that we'd have or tenant that we'd have in our network. So now I can buy one, and then we can separate them out into the device context. Now, for us, if we talk about this as far, and I actually meant to say a Cisco 7000 as I look down. So a Nexus 7000 here, you can have a max of 4 different device contexts is what you can have. You essentially have your basic one, which is the physical device itself, and then you can have 3 additional ones, and that's the maximum limitation. That's pretty much where we got to from our previous episode, and we talked about all the details behind that to make sure that you understood, okay? Now, because we're talking about that unified fabric idea, okay, and everything about it actually tends to lend itself towards virtualization. So these are all virtual contexts here, okay? Now, when we start doing that, remember what this essentially is, Vaughn. If we go back to the separation that I described in terms of virtualization, we have abstraction, right? We have partitioning, and we have pooling, okay? Well, this represents essentially the aspect of partitioning is what it represents. I'm trying to make sure I remembered what I was talking about here, okay? So essentially think about them as individual VMs that are created, but as the switch itself, okay? So that is an aspect that allows us to be able to do more with the same equipment that we have. We don't have to buy new equipment to manage them. We can actually do that. Now, the next technology we want to talk about, of course, is the idea of, well, how do we actually start to work with multiple switches together as well, okay? So, Vaughn, the technology that we're about to get into is what we call virtual port channels. Now, when I say that, you'll actually see this written a little bit differently sometimes too. Let me expand that out so I can type it in here. So you may see the term lowercase v and then PCs like this. So virtual port channels. So VPCs is another way that you normally see this written out. And the idea of the virtual port channel, for those of us that have worked with multiple Cisco switches before, okay, Vaughn, this is where we start running into problems with switches. So for example, the network that I have over here on the left-hand side, Vaughn, okay, everything actually looks good, but we start running into problems when we start to connect multiple switches together. And what we run into, especially at layer 2, is if data comes in onto the switch at the upper left-hand corner of my network diagram that I have, if it doesn't know exactly where it's going to go, it's going to flood it out every other port except for the one that it came in on. And that means data will go towards the bottom and it will go towards the right. And then each one of these 2 switches will do the same thing. So it will send back data across this link and across this link and also here and go across and do everything else too.
It's like they're talking over each other.
They are. And what happens is that it will continue around that point to where eventually it will also send it back to the originating switch. So Vaughn, what we end up with is what we call switching loops, okay? And this is very important because it means that within our data centers and within a cloud network as well, we have to deal with the issue of switching loops. Now, the same way that we actually deal with it in physical networks, what we do, because Cisco switches are very good at this, they're running some form of spanning tree right at the beginning, okay? Remember what spanning tree protocol does for us. It essentially prevents switching loops. The reason why switching loops are really bad is unlike routing loops, which is bad enough by themselves, routing loops will time out after a while. They have a time to live or a countdown timer that says, all right, I've heard this way too often, let me go ahead and turn it off. Okay. Switching loops, though, they don't have that countdown type of timer. They essentially will bounce around forever, and it can be so bad, especially on a very busy network, that it can't resolve the loops. Okay. And when it does that, it just continues to rattle around to where it consumes all the resources of the switch, and it can even bring down your network.
Reminds me when you get those circular reference warnings in Excel and you keep clicking OK, OK, and it just keeps
Yep.
giving you the same warning. You're like, but I don't know what I did. And
Yeah.
then, and then you finally have to like close the whole thing down.
Yeah, but I mean, essentially, it works probably in a very similar fashion that way. Okay, so spanning tree protocol says, "Hey, I'm going to prevent this by simply blocking off some ports." Is what it does. Okay, so it doesn't block off every port, but it wants to make sure that you only have one port. In other words, a single way to get to where that destination port is going to be. So it can work out a massive kind of protocol we call spanning tree protocol. Okay, that it essentially eliminates certain ports. In other words, it doesn't take them off, but what it does is it blocks them from being able to transmit any data on it, so that we can actually have a single loop-free path through our network. Okay, that's in the way of switching of physical networks here. Now, Vaughn, there also comes an issue though. Okay, the more switches that we add in here, so we move it from the idea of 4 switches, Vaughn. What if I have 100 switches? Spanning tree protocol still works, but we also start blocking off more and more ports. The issue with that, right, is if I'm only blocking off 1 or 2 of these ports because I have redundant links in between them. I tried to make them different colors so that we could see redundant links here. Okay, so when we have something like this, overall, it will block just a couple of ports. But Vaughn, once we start adding in numbers that are pretty large, it starts to block off more. But then because we only have a single loop-free path through the entirety of all the switches that we have connected together, it also means that we end up actually losing some of the links that are actually available for us to be able to use. And that also turns into a loss of bandwidth at the same time. So our network that might be super speedy, even if I actually have, quite high-performing switches, it might kind of slow down a bit more because we're essentially blocking some of the ports from being able to transmit data when they need to. So the way that this was now addressed is that spanning tree is not so much of a problem. It actually fixes a lot more than it actually causes problems. But in a virtualized environment at this point, okay, we now have to actually begin to realize something, that what we're talking about in terms of virtualization then is the idea here of doing the abstraction. Okay, so remember we actually just talked about the idea of our switches being able to do the virtual device context as being that idea of partitioning. Now we're moving to the layer of abstraction instead. I still need for something like spanning tree to work. But Vaughn, I'm no longer talking about physical switches anymore. Now they're all virtualized switches. Okay? So in the virtualized switch, if I start blocking off, how do I block off multiple connections in the virtualized network? Okay? So on a regular switch, it's simple. We actually can send a message to a command, to those individual ports and say, what? Turn this port into blocking mode. But Vaughn, we're now talking about software switches is what we're talking about. So how do we get that to function that way? Well, the other way to do this is different, okay? The way that we do it is we take a technology and we move that analogously into the virtual world, and we create what we call VPCs, virtual port channels. Now, Vaughn, in the physical world, we kind of did this as well. We created what we call ether channels. Okay, ether channel allows me to take multiple links between switches, usually up to 8 as a maximum, and I can aggregate them together. So even with 8 separate links together, okay, I can aggregate them together, and then I can actually use and consume the entire bandwidth of all 8 on those connections in between. So for example, Vaughn, let's just take this top link up here that I'm focusing in on, okay? So these 2 links, if they are both gigabit links and I group them together in an ether channel configuration, okay, that means I actually can combine them, and that looks like, at least to the switches, a 2 gigabit link in between, okay? Now, even though it actually looks like a 2 gigabit link, the advantage of this is that we don't have to worry then about spanning tree anymore, because now they're grouped together. They look like one link in between, and even if it blocks off one of these as part of spanning tree, it still has a connection that goes on. Oops, didn't mean to do that. Sorry, didn't realize I had clicked on that. Okay, so even if it blocks one of these two connections inside, it still doesn't matter because we can still send traffic over it because it's still connected in that way. Okay, we take that same concept into the virtualized world, and now what ends up happening is that we do the same thing here. So normally the way that Ether channel is identified in topologies is this idea of this loop that we combine together. We're saying what? We're bonding them together. We're aggregating them together. And we can do it between these two, like what I show up here at the top between two switches. And now, Vaughn, that means on these switches, it looks like a single link in between them. Okay? If I have a server and I have two different NICs, I can even do something a little bit different here. Even if they're actually connected to two separate switches, Vaughn, I can bond them together in this way using virtual port channels. And what it looks like to the server is it's just connected to a single one switch. So even though it's actually connected to two, at least to the server, it goes, oh no, that's just one connection. Okay, so that's why it's the virtual port channel. So in reality, like if you go into an actual regular Cisco switch, you type in show port dash channel, okay, right there, you actually see that that's exactly what we're using, is we're using a port channel is what we're doing here, but this time they call it a virtual port channel to help us out. So it helps us to get away from that idea of having to worry about, spanning tree causing a disruption in what we have together as well, okay? So it actually is a combination of that, but the true kind of virtualization here, right, is abstracting what we know from the physical world and making that work inside the virtual world. So we're abstracting that same concept, and we're actually saying the software can handle this and make it work together in the way that it needs to. All right, that's a big one. And then, of course, you can also add in a little bit of what we call VCP pooling into this as well, where we are actually making sure that that's exactly what I showed you in terms of my diagram here. Let's take a look at it again. Is that when we talk about VPC pooling, so even though traditionally it would actually be two connections in between, let's say this server and this switch up here on the top, well, we can actually do two separate ones, and what it looks like it's connected to is a single VPC pool is what it looks like it's connected to. It doesn't have a clue that it's actually connecting to two separate switches, okay? So that's a big part of the technology that's also inside that Cisco unified fabric that helps all those components work together, all right? All right, so Vaughn, that is one of those other technologies. So we've talked about a lot, right? So we understand that that idea of the data center and the goals that we're trying to hit. But what helps us to achieve those goals? Things like the virtual device context, and now the VPC, the virtual port channels. But now there means there's some other things that we have to take a look at as well. So the next particular one that we're going to go to, and we already talked about this a little bit in a previous episode, so this is more of a reminder, but we're now adding in just a little bit more information to this too. We talked about the idea of what we call fabric extenders, okay? With the fabric extenders is exactly like it sounded like. The very fact is that it allowed us to connect to more than one device at a time to help us to achieve the switching that we needed to. Well, there's a couple of different ways that we can actually do this, okay? So Vaughn, let's take a look at this diagram here just for a moment, okay? So if we use fabric extenders, which don't necessarily have to be the physical devices themselves, they can be virtual as well, okay? We can have what we call single link fabric extenders here, okay? Now, Vaughn, if you take a look at this diagram over here on the far left-hand side of the screen, okay? Now, Vaughn, I see, well, two connections in between these switches here, and in between the switch and the server at the bottom or towards the middle of the screen, Vaughn, I also see two connections here. So why would I call that a single link? That's the key for us to actually think about, right? Because you're saying, hey, that's not a single link. That's two links in between each of those devices, right, Vaughn? That looks like two links.
Yeah, but it's just like what you're talking before of almost. I was thinking like you twist tie them together.
Mm-hmm.
You've got two, but you're making it act as one, or how it's recognized as a single link.
Good. So I didn't throw anything past you, Vaughn. That's what I want to make sure of. Okay. So I did not throw anything past you. But when we talk about a single link and what a fabric extender does, it's always about the uplink. Okay. So traditionally, when we talk about uplinks, it's normally the links in between two switches. In other words, our network infrastructure devices. Okay. So when we do this in the virtualized world and we start to actually do this, we instead can, of course, use that VPC. So there it is, Vaughn. I didn't throw one past you right here. You saw my little diagram, and you saw the little ring that I also put around here. Notice that it looks like a single link in the link between me and the switch, and also in the uplink between this switch and this switch. So that means that our switches, even in this hierarchy, they actually only appear as a single link in between. Okay. Now, Vaughn, that makes sense because that one's pretty much straightforward. But now, Vaughn, what if I actually take a look this way? Okay. Well, now all of a sudden it looks a little bit stranger, right? So here's 3 links. Okay. And then here's 2 links that I have. And it looks like that, Vaughn, these are actually connecting to 2 different links up here.
Because you said that you can actually have it go to 2 physical different
Right.
switches, but still remain. Because before it's like, okay, it's going to the same destination, but it's together. Here you can bundle them all together to go across multiple devices.
Right. Yeah. So this is still the same. If you notice, once again, here's 1 link, and then that goes up here. And this one, even though it actually looks like 2 links, it goes across here too. Now, I left this on purpose this way because this is actually 2 different links. But notice, Vaughn, it is actually just a single link in between. So even though I have dual connections in there, there's really only 1 path that goes in between here and here. Okay, so that's what we have. So, and then this one is also treated as a single link as well. Okay, so this right here, not exactly the classic way of looking at it, but this is single link. Now, this one is normally going to help us out because we're actually connecting that upstream switch with this fabric extender. So you can purchase that, or you can set that up, right, in terms of whether they're single link or not. Now, most people, okay, the more traditional idea is what we call dual homed instead, okay? Now, Vaughn, on this one, this is strange in this way, okay? Notice that at every layer of this diagram, though, okay, both devices, even though they're actually treated as one, okay, and they actually look like that they're only going to go across one, notice that on both layers, they're actually directly connected to actually both devices. I'm trying to make sure I'm saying it correctly. So even though it's treated as one, okay, the very fact is I still have physical connection. So if I am instead going from my single devices like here, and I am ultimately still going to be connected all the way upstream, all the way through everything else, and they're actually directly connected to both of those devices, unlike what I showed you in the straight through here. Notice the comparison. This is really just 1 path that goes up, okay, right? So between this is still just really 1 path. It's not actually saying I can go this way and I can go this way. It says either one of these paths, we're still going along that 1 path. But now, with the dual homed connection though, okay, once we get to the switches and we get to the uplinks, notice that if one of these paths fail, what can happen, Vaughn? I can go to the other switch, okay? So that's the difference between the dual homed versus the single home, okay? So here, even though I want them treated as a single link, this is more about the failure of a single link that I can still go across and actually get access here, or I can come up here and get access as well. And that's the same that's true up here too. Either way, it actually helps us out in that sense, okay? So that is the uplink when we start talking about fabric extenders. Now, I did this to the server because you can also, of course, use your fabric extender so that you can connect that way. But traditionally, they're really all about the uplinks, which are between switches, okay? So if our network here is actually done that way, that's what we'll also end up seeing, okay? All right, now, there's one other term that we need to also, of course, talk about as we go through this, okay? Vaughn, there's a term that we call the idea of the fabric path. Fabric path is just saying that we can actually make it to where the idea of us sending the data across multiple paths if we want to, instead of just saying what is the best path to go across, well, we can use the actual fabric path itself to allow for what we call multi-pathing at layer 2. Okay, so layer 2 multi-pathing means we can actually take either one of these paths, and it's perfectly fine, and that can be configured as well. All right, one other technology that we can actually take a look at as well. Okay, so Vaughn, right here, this is the one. So Vaughn, I'm going to let you pronounce this because I did such a terrible job.
Oh
Notice
man,
what we're
I was
actually doing
really
here.
hoping that you were going to go ahead and try it again.
All right,
because,
Vaughn.
no offense, that was
you,
quite
all right,
fun to watch.
Yes. So Vaughn, you take a shot at this because I'm not going to be able to say it.
Cisco Algo Booster? Or
Algo,
Boost?
algo.
ALGO.
Yeah.
Algo?
So algo. Yeah.
That's how I'd say
So
it.
I think that's what I tried to say, and it never came out right. Okay.
That was
So
fun.
this is another technology, but this is all about, of course, increasing performance. Now, Vaughn, this doesn't really sound like much to you and me sometimes until we start realizing what is the commonality here. Okay. So let me see if I can find the paragraph that I'm looking for. As what I'm wanting to do here. All right. So traditionally, right, they're saying, look, a lot of times delivered switch move packets can move from one port to another in less than 250 nanoseconds. Okay, so that's pretty fast. Okay, but what they actually have achieved here with Algo Boost is that they're saying ideal high performance trading, big data, high performance computing environments. This technology offers network access performance as low as 190 nanoseconds here, more than 60% faster than other full-featured switches. Okay, so that means that the Nexus devices that have Algo Boost, okay, and here they're actually using it with the 3548 here. Okay, this particular technology can actually boost the performance that we need, and we're going to be talking about the idea of performance when we get into the SDN type of things that we talk about, as well as the ACI type of technology too. Okay, and we'll be mentioning that a little bit later on. All right, so Vaughn, one of the things that I hate to actually have to spend a ton of time on, so I've actually saved the last few minutes for this so that we don't spend a ton of time on this, is that Cisco really wants you to know about some of these device licenses. I wish I could tell you, no, you don't have to know about any of them, but I'd be lying to you. All right, so Vaughn, we're quickly just going to show this, and you can find this on any Cisco website. And I've got them aggregated together. Remember, if you're an IT Pro TV subscriber, you'll be able to get access to my show notes here. That's exactly what I'm using at this point to help us out. So notice that in the Cisco Nexus 5000, which is what they specifically call out on, you can see that you can purchase licensings to help you to do different things. Okay. So there's an 8-port storage protocol services, which includes fiber channel over Ethernet as well, and then the idea, of course, of 8 ports that you can do. There's a lot of different features here, and make sure you understand that idea of multipath if you need it, that you might have to actually think about the licensing here or what particular Cisco network device can help you to do that. The idea, of course, of routing, and notice that you can actually do a lot of different routing here as well. Okay. So that's also a possibility. If you need to use fabric extenders, remember that the Cisco 5000 will also do that for you too. Okay. Now, the one that there's actually an evaluation copy of, okay, an actual simulation of that you can get access to, which is a virtual switch, which is the Nexus 7000. This one has a ton of different licensing packages once you get in this. This is more like a full-featured switch here, Vaughn, okay? So everything that you can think of. But here is the key feature that we want to make sure that we understand. If we're going to be running virtual device context, okay, we're going to need to at least do this with the 7000, okay, is what we want. Yes?
So is that what they're trying to get at for the test of like understanding the differences between some of their devices and what licensing is available for which ones?
So, yeah, to a point, right? In other words, the features that we've just talked about, you got to realize that they're not available, such as on some of the 5000, okay? So they're not going to which license exactly is this going to come in from? You got to at least know what particular model that they come in from as well. So let's go back here, and you'll see that there's some other ones here, and I've got all these lists out. I'm not going to read through every single one of them, okay? But just kind of realize that if you need to, go back and check out the licensing for the Nexus 7000 and the 7700, okay? And then when I get to the 9000, there's not so much of the 9000. That's because all of those features are also usually included in to the 7000 as well, okay? But notice they have enhanced layer 3 here. Look at that. Oh, look at that. VXLAN is also right here, something we've already talked about. And then another feature that we haven't talked about yet, which is the data center network management. This is everything that we can do can be managed through this particular device as well, okay? There's a few other things that are out here, but just realize, make sure you pay attention specifically to the Cisco 9000s, to the 7700s here, the Nexus 9000s, Nexus 7000, 7700, 5000s. We did a whole episode, Vaughn, on the Nexus 1000V, which is their particular one that they ended up using the most in just about everything that they did. Now, ironically, it's probably not going to even be hinted on the exam. But Vaughn, I looked it up the other day, and the Nexus 1000V, its end of life was actually February of 2019, which is actually just a month ago. But you'll probably still see it on the exam. So it doesn't mean that it won't be supported. It means that they're no longer actually actively selling that. So it is the heart of what a lot of our exam is also focused in on, to make sure you pay attention to that. These devices, not so much so, but for those of you that's going on towards, let's say, like your CCNA data center as well, and understanding, of course, your CCNA cloud administrator or administration, make sure you check those out. But as far as the licensing features go, anything that we've talked about in the unified fabric, you've got to remember where those particular pieces come from and which one that you might choose to be able to use if you needed that. Okay, so Vaughn, that should end our overall nice review and understanding, at least an introduction, I should say, to the idea of the Cisco Unified Fabric and all the components that are involved in here. So over these past 2 episodes, we've gone through quite a bit of material.
That is true, Ronnie. Lots of great information that we need to cover, not just to understand the concepts, but what is going to be on that exam. So thank you so much for joining. But we're going to go ahead and sign off for IT Pro TV. I've been your host, Vaughn Smith.
And I'm Ronnie Wong.
And we will see you soon.
Thank you for watching IT Pro TV.